So we left off with the idea of wanting to make friend objects. And we're going to put the friend objects in a like a contact list. And all the friends are going to be the friend class. Every instance of a friend, all I'm going to want to do is just store some data about friend. The class really is just about the data. There will be some functionality attached to it, but the functionality really is just about that data. It's not going to do very much, but that's by design. Sometimes it's nice to have functionality and data quite separate. The friend list, the contact list, that's going to be a little bit more complex because it's a collection. So each friend, we're going to want a first name, last name, email address. And we're going to want some behaviors involved with the friend class. So this would be the functionality. But again, like I said, the functionality is really going to be focused on the, on the data. And it's going to be accessors, getters, we call them often, ways to get data, the fields, because we set them to private, or we want to set them to private. And we want to check if two friends are equal, right? And we're also going to want a toString. That would be what we were familiar with in Python, the repr, but some method to return a nice string representation of that class. So that's what we want. And if we're doing this in Python, this is what we would have, right? We have our constructor, name of the class, the constructor. The constructor is always called __init. And in Python, every method inside of a class had to start with that self keyword, although it's kind of a keyword. And then all this did was take 3 parameters and then immediately assign those parameters to fields for the class. And remember that first name and self.firstName are entirely independent. This parameter first name, it's the same as this one, but this is different. That's one that belongs to that instance. And all this class did, all this constructor did was assign some fields. That's all it did. It's a common pattern for a simple class. That said, if you don't need one parameter for each field. No, it depends on what the functionality is going to be. So don't think that this is the way it has to be. It's just I'm showing you one example. To do the same thing in Java, we would write something like this. You see at the top class friend, but it's public and it's final. Public because we want it to be accessible. Final because, well, that's a keyword we can use to basically mean that any instance of this is going to be immutable. Once it's created, it's not going to change. That's what that means. Similarly with those fields, I've got 3 fields there: string first name, string last name, string email address. But there's a bunch of keywords involved. Private, these fields exist, and they're usable within this class. All the code within the friend class I'm going to write can have access to these fields. But outside of that class, no. They're private, they're not accessible. At least not without very well-defined control that we're going to implement, the getters. And final, because again, once they're set, they shouldn't be changed. Do note that the way this is being implemented, using the keywords final are really not that necessary, but it would be a good choice to use them here anyways. But it won't really have a functional difference. But when you use the right keywords and right use of these tools, it just helps other programs know what your intention, other programmers know what your intentions are. And then the constructor. In Java, unlike Python, Python's constructor always had to be called __init__. In Java, our constructors are always the same name as the class. And the constructor actually doesn't, it's a method, but what's special about it is it actually doesn't have a return type, right? Every other method would be like public, string, something, and it would return a string. This one doesn't actually have a return type specified, because this method is actually kind of like returning the instance that's being created. And you'll notice we actually don't need a self keyword. In fact, Java doesn't have a self keyword. It has a this keyword that means the same idea, but we don't need to include it. And you'll notice I have 3 parameters there: first name, last name, email address. And all this constructor is doing is taking the values stored in the parameters and assigning them to the fields associated with this class. A couple of things I want to emphasize here. Just like in Python, the first name right here and this one are the same. This one, the one with this in front of it, entirely different. They're entirely independent from one another. That one belongs to the instance. That one's an actual value tied to that instance. They have the same name, and that's just because coding-wise, it's the first name, right? But they didn't actually have to have the same name. The fact that string first name was called first name in the parameter list really didn't matter. I could have called it A and then said this.firstName equals A, and it would work just fine. But of course, A is a terrible name. What's a good name? Well, the first name, because that's what it should be. But then that raises a bit of a problem of, well, we've got some ambiguity. I kind of have like two variables now in the class, at least in this method here. Two variables with the same name, first name. How do I resolve that ambiguity? Well, the this keyword is what does it. This dot first name means the one that belongs to the instance. First name is, well, the one with local scope, the one from the parameter list. So here's what I'm going to do. I'm going to start by going here, new Java class friend. Great. And I'm going to go here, and I'm just going to copy everything and close the class. Cool. And I'll get rid of the Java docs here for a moment, just because for the sake of space. So with this, well, first of all, I didn't actually even need a constructor. Without a constructor, I could go start making instances of a friend class. It would just be, they would be absolutely useless and have no functionality or way to store data. But I could. But now, at least with the friend class, I can go ahead and create an instance. Any questions about any of that? I'm going to revisit this in a moment once we do the accessors to show you a little bit more about what I meant about the names of the things not mattering too much. Well, they matter, but you'll see. Okay, no questions. Everyone's happy. All right, so this is just explaining what I already did. Okay, accessors. So like I was saying last time, here, I'll just show you now. Here. For the sake of demonstration, oh, that was weird. I'm going to make these fields public. We typically don't want to do this, but I'm going to do it to show you. So I can go back here to my main. It's called lab2 just because we were using it in the lab yesterday. And I can make a new friend. Friend, my friend, equals new friend. And it needs a first name. There. It needs 3 arguments, right? Because the constructor says it needed 3 arguments. The syntax for creating an instance of an object is nearly identical to Python's. The key differences are, well, we need the variable. The variable is called myFriend. But we need to specify the type for everything. And when it comes to objects, the type is the class, friend. And then on the right-hand side, we just call the name of the class. But the biggest difference here is in Java, you need to use that new keyword. You say new friend, where in Python, you didn't need to say new. Whatever. But the idea is the same. So now with this, I could say, okay, no. So whenever you have like an instance, I can say dot, and like IntelliJ is going to show me a list of things I can do with it. And you can see I can actually access those fields, email, first name, and last name. Sorry, I'm pointing over there because I've got my little display there. But yeah, you can see them there. So when I say email, when I hit run, what would you expect to happen? Which in this case is ZXC. If it, it's thinking. I discovered in lab that it seems like the reason it takes my computer so long to do anything is because it's trying to record at the same time, and these computers aren't particularly powerful, so FYI. So ZXC, great. Now, like I was saying last time, just to really drive the point home, I'm going to make another one, my other friend. There. Okay. Take a moment, look at this code, and in your head, lock in what you expect to see printed out. I'm going to hit run, and you're going to tell me if you're right or wrong. There should be nothing about what you're about to see should shock you at this stage. Yeah? Why? Well, both of those friend objects have email addresses, but they're independent. The friend object referenced by the reference variable called myFriend, its first name, when in that context, that myFriend, this first name, this email is ZXC. But my other friend, their this.email is, BNM. So be aware, they both have an email, but they're independent from one another. Each instance is unique. Now, they're public though, and that's why I can access them like this. But we don't really like that. That's really not what we want. These really should be private. And the reason is, well, first of all, look, IntelliJ is already mad at me. I think I showed you this last time. If I try to run it, it's going to say can't do it. It won't even run. It won't even start to run. It'll say you can't. Fix your code, like I was saying last time. But you're going to say, but I want to access that field. And I'm going to say, well, the problem is if I give you public access to that field, someone could modify it, and we don't want that to happen. Whether someone modifies it intentionally or not, realizing that it's going to cause an issue, either way, I want to have nice, good control of the program. No one should be able to modify this field. So I can't give public access. So what I'll do is I set it to private, but then I write code to facilitate the specific use cases of that field. For example, accessors are common in situations like this. Now, not every field needs an accessor, and we'll see plenty of examples of that. But in this example, we'll have 3 accessors. One for get email, get first name, get last name. That's what you call them. Get field name. And I'm pretty sure, check this out. IntelliJ will actually auto-write them for you, which is pretty neat. Look at that. Good. No. I was just doing it because it's cool. But otherwise, you'd write the whole thing out. Public, it's public. Return type, string. They're all strings. And then get, first name. And all it does is return first name. Last name, return last name. Get email, returns the email. That's all. Now, you may look at these 3 fields, the first name, last name, and email, and say, how come I didn't put this in front of it? Raise your hand if you notice that. Yeah. Well, you don't need it in this context because there's no ambiguity. The first name in that parameter list only exists within the constructor. As soon as the constructor's done running, that disappears. It's gone. So this class has no memory of that. That's why we had to store that value in a field. So here, it knows that, well, there's no ambiguity. It obviously means the field. If you prefer more explicit code, there's nothing wrong with saying this.firstname. That's entirely fine. I won't include it here, but if you think it's really better with this dot in front of it, by all means go ahead. They do mean the same thing. There's no functional difference at all. But those are the accessors. So with these, I have a way to get that information from the class, but I have no way to go into the class and change anything about it, which is nice. So if I want that email, I don't say email, I now say get email. Get email. Now I would run. There, and it works. If I really wanted to make this code stateful and I really wanted to be able to go in and modify the values in there, which I don't, but if I really wanted to, what people would do is they would use mutators or setters. You would write a function called setEmail or something that would take a parameter that would just update the value of the field. I'll show you an example, but I don't really think I'm going to ever ask you to do this in this class. Set. Look at that. Look at IntelliJ doesn't even want to like autocomplete because it knows. Public void, it doesn't return anything. And then I would say, here I would have some ambiguity, so I would say this dot email equals email. There. So that would be like a setter. And what's it mad about? Oh, because it's final. So it's saying like, well, you really can't do that. But if it wasn't final, it would have been fine. Now, one thing to note, too, going back to the beginning, I'm going to change this to A, B, B, C, C. There. The names of these parameters don't matter respective of what the fields are called. They really don't. And because there's no ambiguity anymore, I actually don't even need the this. The way I have it here is going to work just fine. That said, this is some pretty awful looking code and is not really typical, but this will function just fine, and I'll prove it. Let's run it and make sure I'm not crazy. There, it's working just fine. The only reason people sometimes get a little apprehensive of this is the ambiguity, but this is a very common pattern just because, well, what do you want to call the parameter that's going to be called, that's for the first name? First name. What do you want to call the field for the first name? First name, right? It's a good name. One workaround I've seen people do is they'll do like first name. So, okay, fine, yeah. I don't recommend that, but, you know, just an idea, that's all. Okay. Any questions about any of this? Yes?
The accessors, like those, you said those are important because you don't want someone to be able to edit
The fields.
the fields, yeah.
Yes.
But if the fields are set to
Final. They can't be. So, I know what you're asking. And someone asked this in lab yesterday too. Who was it? I don't think they're here right now. And that's a good observation. Now, when the keyword final is very general purpose, and depending on how you use it, it's used a lot of places. So, let me clarify. Your point you're making is, well, you set that keyword to final, so it doesn't even matter if you did a setter. They wouldn't be able to change it anyways, right? And you're absolutely right. But right now, this is more of a design decision in terms of what the code looks like. When we write the code, like the way we interface with the friend class is through the available methods. My friend dot. And this is like how we can interface with it. And when the interface is, if I set it to final, but also included a setter, then the interface would be in conflict with that final keyword. The final key, with the way I'm going to design this class, the final keyword is somewhat redundant because it's not going to be possible for me to make it, to change anything. The class will be immutable because there's no way to modify anything. But the final keyword is just an extra layer of Java that's going to be like, nope, no, nope, no, 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 no. So you're absolutely right. We're doubling up on like, nope, don't touch me. That's all. There are a lot of people, though, that will never use the word final. If on your assignments you didn't use the keyword final, I'm probably not even going to notice. The TA might, though. I don't know. Other questions? Good observation, though. All right, so those are the getters. And now a toString. You remember in Python the toString, really we want our toString first and foremost, always, always, always. toString does not print anything. It returns a string. Always returns a string. Common mistake new programmers make is they think it prints something. No, it returns a string. And we want our toString to be the best string representation of that thing, that object, for our needs. Now, in a lot of cases, a toString, I really don't care what it looks like, right? Maybe for something like a list, you know how like in Python when you print out a list, it's kind of like formatted as if, there's like, oh, I can see each thing in a line in a list. So there's some design in how that toString or that repr worked. But for a bunch of other classes, I actually don't really have anything specific in mind. So there's a common pattern. Name of the class, parenthesis, field values, close parenthesis. That's a common pattern like you would see here. This is what you see there in Python. And we're going to do the exact same thing in Java. Now, this is an F string, right? In Java, we don't have something as nice as an F string. But F strings are really just syntactic sugar for something more like this. Right? These are basically the same thing. String.format. Now, I didn't even need to do this with string.format. I could do that thing where I say like string, close string, plus some other string, plus. Like I could do it with a bunch of pluses. That's pretty ugly and gross. So we do it this way. It's a little nicer. But to each their own. But there's the toString I'm going to include. So that will tell me friend, and it's actually kind of interesting. %s means insert a string here, insert a string here, insert a string here. And then after that, we say, well, which string goes first, which string goes next, and which string goes after that. That's the style. That's how it works. This is actually a very, 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 very old system of doing like strings from like decades ago that just kind of stuck around because it is what it is. I mentioned in lab, and I think I mentioned in lecture before, I always think it would be so cool to have like a course on like the history of why we do things the way we do and how stupid most of them are, but we're just kind of stuck with it because it is what it is. Someone 40 years ago did it that way, and we're still doing it that way because. Yeah. So there we go. But do you remember in Python, if I didn't write a repr, there was actually one there for me for free. I could call a repr on anything in Python, even if I didn't write one. Same with I could check a quality on things in Python, even if I didn't define a quality. It was there for free. And in fact, look at this code. Do you see a toString in this class anywhere? Say no. No. Yet when I go here, and I say my friend dot, we will see a toString is in fact there. It's because it's there. You get it for free. Whether you like it or not, Java ensures that every class has a toString. It also ensures that you have like a get class, notify, wait, hash code equals. They're all there. They exist. But the ones you get for free are often not that useful for your situation. They're there for free because Java needs to ensure that they are in fact there. Whether you like it or not, they have to be. So there actually is a default behavior for a toString. And I'll show you. My friend.toString. And I hit run. We see friend at EED1F14. That's what we see. What is it telling us? Well, it's telling us the name of the class at, and then like part of a hash code, basically like kind of like where in memory it is. That's what it is. Not that helpful. I mean, the most helpfulness you get from it, so actually, by the way, here, I'm going to show you another example. You don't actually need, it's the same in Python, actually. You don't actually, my other friend. You don't actually need to include the toString in like system.out.println. It'll call it for you automatically. So this was actually kind of unnecessary, but whatever. There is some usefulness in the default toString. I mean, it tells you the name of the class, so you know, that's something. Chances are you knew that already, but you know, it's something. But what's kind of neat is it will like, oh, okay, you know, those two, I mean, they're both friends, but they're different friends, right? Remember your whole reference variable thing? Do you think this makes a copy of the friend object? Say no. No. All it does is it makes a copy of the reference to the friend object. So if I go down here and print out alias for my other friend, the name of the variable should have made it obvious it was an alias. Works the same way in Python. If I print those two variables out, we'll actually notice that, well, the thing that it's actually referencing is, in fact, the same thing. Though that won't work once we start to get to the equals. I'm just talking about the default behavior here. Cool. Any questions about that? Now, we're going to implement our own toString. It's this. I'm just going to copy and paste it. Go here. There we go. So I call it, and I want to return a much nicer string representation of my instance. So I've just replaced it with the toString. And we see friend with QWE ASD X ZXC. There. Cool. That's all. A much more helpful version of a toString. And this is a common pattern that you'll see with objects where you don't really have anything in mind for what the string representation should be. Just make it look like that. Cool. This is much nicer. But no, I could make it whatever I want. If I wanted, I could have said, there. Whenever I call toString, it returns the string, this is dumb. It's not very useful, because every instance will be exactly the same. It'll just say, this is dumb. But I could do it. All that matters is it returns a string. That's all that matters. In practice, it returns a string that's useful. You may also have noticed, people in that lab yesterday noticed this little thing over here. IntelliJ kind of showed this little O with a little up arrow next to it. And if you hover over it, it says override. This basically means, okay, we got a toString for free, but we are rewriting the exact same method with the same signature, toString, in our own class. Which means ignore the, forget the one you got for free, use this one. We are overriding what you got for free. That's all that means. Cool? Questions? Anything? All right. Yeah, we could have done it like this if we wanted. Instead of that, we could have done this. And this would be functionally equivalent. Just, I like the string.format a little nicer. I think it's more generally nice. Oops. And again. It returns a string. It doesn't print anything. If your toString prints something, you've messed up. Any questions? Yes? How do I copy a class? Okay, what do you mean when you say that? Do you mean make a copy of the instance?
With a different reference.
Well, there are several ways we can do it. We could use like a factory method. There's a lot of ways, right? We could do it however we want. Common ways would be like have a special constructor that takes a reference to an existing one and just copies over all the fields. You could use a factory method, which we'll talk about a little later in the semester. You could just kind of manually do it in your main by extracting the values and creating a new one. There are a lot of ways. So are you asking because you're familiar with like C++? Okay, well, in C++ you would usually have like a copy constructor as well. So there are ways. Yeah. Was there a specific reason you were wondering? Or were you just kind of just wondering? Okay, yeah. Good question though. With a nuanced answer that I kind of don't want to get into. Other questions? I like questions. It's boring to just stand here and talk at you. So this means everyone's A-okay with everything. Yeah? Raise your hand really high if you're A-okay with everything. Really high. Look, everyone's hand's up. That wasn't very high. Does that mean you're maybe not that comfortable? Maybe. All right. All right, equals. We need to define what it means for two instances of the same class to be equivalent. What does it mean for those things to be equal? If I have two friend objects, when should they be considered the same? We get a default equals. It's the same as equals equals. But remember that equals equals actually means something a little, equals equals means something special. It means something, it means when I have a variable and another variable and I use equals equals on them to check if they're equal, what I'm really checking is the contents of that chunk of RAM. What's in that memory? And if the contents of that memory is the same, it's true. So if I have some primitive type like an integer in that memory, I'm going to draw my paint skills. So we have two variables. All right? We'll call this A and B. Now, if in here I have the number 1, and over here I have the number 1, and I say, hey, A equals equals B, what do I get? What about, if I can find my mouse, where is it? Okay. 2. How about now? Well, because the contents of memory are different. But remember that objects are weird. I mean, they're really not, but they act differently than primitive types, except they really don't, but they do, but yeah. So imagine I have two objects. Right? And I'm gonna just, there. Woo, woo, woo. Okay, great. And I'm gonna make a copy of this object. It's exactly the same in every way. All right? And when I have an object in memory and I say A equals like a new friend, so let's pretend these are friend objects. And I say A equals a new friend, the object is not stored in A. A reference to the object is stored in A, right? Because we can't shove an arbitrary object in a nice, well-understood chunk of RAM, like an integer. We know integers take up like 4 bytes, right? So I know how much the computer is happy to, 4 bytes for an integer. An object, I don't know. Like think about a string, right? If a string has 2 letters in it versus a string having 5 million letters in it, there's going to be a difference in how much room it takes up. So the computer doesn't really know. So it sets aside a chunk of RAM later and then just assigns a reference to it, so we're happy. Now I'm drawing these references like arrows, but really it's going to be like memory address 5575. That's an arbitrary number. And then over here, I've made a copy, an exact copy of that object. They are equivalent in every possible way. And I said B equals that copy. And again, I'm drawing this as an arrow, but really the contents of B is going to be AF21. Again, some arbitrary hex number. So when I check, does A equals B? Here, let me actually put some numbers in there just. Selecting that font drop-down, this computer just started going like, ooh. There we go. If I say like, right, and then down here, it's, right? The arrows are representing some memory address where you can go find the actual object we care about. When I say A equals B, it checks the contents of RAM. Are the contents of those pieces of RAM the same? It's not a trick question. Does 572673 equal F87678? No. So it's going to say false. And you're going to say, but they're the same. And I say, that's not what equals checks. Equals checks what's in RAM. If, on the other hand, I had this, if I said B equals A, what am I copying? The contents of A. If I said B equals A, I have this. Right? And I don't remember what number I put in here. There, that one. Now, if I say, does A equal B, what would it say? True. Equals checks what we call sameness. Is it literally the same thing? I don't care if they're equal, it's are they the same thing? And those are two very different things. Now in this example, in the previous example when I had two circles, how many circles were there? Two. I know, sounds like a trick question, right? So there are actually two circles and two variables. Now I have two variables, but how many circles? One. Yeah. Any questions about that? So, in order to check, okay, are the actual objects the same? We need to define the equals. And just like toString, we get a default equals. Anyone want to take a wild guess what the default equals does? I don't expect you to know, but someone could probably guess it. It does. The default one is equals. It does the same thing. That's not going to be useful for us. We want to define our own equals. And that's what we did in Python as well. Now, interestingly enough, remember how like in Python you define equals as underscore, underscore, EQ, underscore, underscore, but you never actually invoke that method directly. You would call it by using equals. And whenever you called equals with those objects of that type, Python was smart enough to go like, well, okay, that's actually in the underscore, underscore, EQ method. Java, no. In Java, we write a method called equals. And we write a method called equals, and you don't call it with equals. Equals is still reserved for sameness. You call it by invoking the method directly, and you'll see examples of that. So here's how we did it in Python. Here is an example of a simple one. Def underscore underscore EQ, self, other, and it returns a Boolean. First it checks if it's actually, if other is an instance of a friend. Because if it's not, they're not equal. If other, it's like if I ask you, hey, are you equal to a bridge? You're going to go, I don't even need to check. I'm not, right? Like I'm not, bridge isn't a human, so I can't start comparing. So that's what the if is there. And if other is a friend, well, then we go in and we check, okay, is the first name the same? Is self.lastname equal to other.lastname? And self.email equal to other.email? That's how we would do it. And that's what we want to achieve here in Java. But in Java, we got to be a little bit more verbose. But all of it makes perfect sense. So oh, by the way, on some of the methods, you might notice this little @ tag, like it says @ override. That's not necessary. You don't need to include that. That's just like a compiler tag, so the compiler's like, yeah, that was an override, yay. Whatever. Public Boolean equals object O. So the way this is written, and I'm going to warn you, there's a lot to unpack here, and I'm not expecting to be an expert in this after my little rant. Every class that ever exists somewhere in a hierarchy, okay? And at the top of that hierarchy is the object class. Every class you write is below, in that hierarchy, is below the object class. It actually inherits from the object class. Everything you write is an object, okay? Whether it's a course, a country, a friend, they're all objects, and there is an object class. And in fact, in that object class is where the default toString was written, where the default equals was written. And in fact, I'm going to prove it to you. If I go back here and I click this, IntelliJ will actually take me to the, look at this. Look at the name of the class, it's object.java. And the default toString is getClassName.getName at integer.toHexstring. That's literally the code that was run by default. That is the code from the object class. And we could probably find equals in here as well. Right? And what it checks is if this is literally equals the other object. That's the sameness check. But we're going to override that with our own equals. So we start by saying, look, you should be able to, because Java is very strongly typed, this really didn't matter so much in Python, because in Python all I did was say, hey, is this thing even a friend? If it's not, ignore it. In Java, we say, okay, you're checking if this friend object is equal to some other thing. But that other thing might not even be a friend. But it must be at least an object because everything's an object. So I'm going to start by assuming that thing is just an object. And the first thing I check is actually sameness. If other, actually, if other O, if O, which is the other one, is actually equal to this, that's the sameness check. If they are literally the same thing, they're equal, right? They just have to be, right? So that's the first check. And if that's true, there's no need to check anything else. We're done. Now, if they're not literally the same thing, this would be the example I mean here, assuming I still have it open. That would be this. If I said A dot equals B, the first if would flag. A would be this, B would be O. Are they literally the same thing? Yes, they are. They are then by definition equal. I am equal to myself. If that's not the case, I check, well, is O null? If O happens to be null, remember how Python there was that special value none? Null is none in Java. In fact, null is null in most other languages. Java's the weird, or Python's the weird one. So if O is actually a reference to nothing, they're not equal, right? Hey, are you equal to literally nothing? And you're going to be like, well, it's a weird, no, right? That's a stupid question. Then I say, okay, if O's class is not the same as this's class, basically the check, are they both friends? If they're not the same, well then false, they're not equal. And after all that, I can finally conclude that if this if didn't get tripped, so when I say this.getClass, it's going to say friend. So other.getClass, it returns its class. If it's friend, they are equal, so this wouldn't trip. So after this is run, I can confirm that other is in fact a friend class, really. Then what I say with this syntax here, this is called casting. And we don't do this very often, but this is one of the cases where we do it often, is we are saying, okay, O, you're a friend. I've confirmed you're a friend by that check on that if statement right above. So I'm going to create a reference variable that here I'm just calling other. I'm saying O is, okay, other, and it is in fact a friend. So I'm basically telling Java, this is a friend. I'm confirming, if I was wrong and this wasn't a friend, the program would crash. But because this will be a friend, because the if statement on line 69 there would confirm otherwise, I'm saying, treat this as if it's a friend. Because before, all I know is it's an object. And if I ask that object, hey, O.getFirstName, the object doesn't have a getFirstName method. The friend class does. So I need to tell Java, okay, this is actually a friend. This is a friend object. And then Java's like, okay, great. I can then access the friend class's methods and fields. All right, so after all that, and I've confirmed other is in fact a friend, I can then say, now, this dot first name, I'm calling objects dot equals this dot first name, other dot first name. All right? This is kind of weird, but go with me. It's effectively asking, are their first names equal? Strings are objects. In reality, strings are funny objects in Java. They're a very special object where sometimes they pretend to be primitive types, kind of. But because they're objects, we don't want to compare strings with equals equals, because it's going to do a sameness. So we want to use like a dot equals to check equality. So this is how we want to do it. So we call objects dot equals on the first name. So if the first names are equal and the last names are equal and the emails are equal, well, return the result of that Boolean expression. If they're all equal, it's going to return true. Otherwise, it's going to return false. Yeah? Now, I realize this is quite a bit to unpack. And this is one of the things in the semester where I'm kind of throwing it at you, going like, I know it's a lot to unpack, deal with it. For the time being, whenever you go to write an equals, whether it's in the lab or on an assignment, you've got a point of reference. They're all going to follow the same pattern, at least for a simple class. So for the time being, just make it work. I can talk a little bit more about objects.equals maybe next time because we are running low on time. But any questions about any of this? Okay, yes?
So does casting only work because O was originally an object and you're like going down? Or can you do that with anything?
So you can downcast, and you can try to downcast on anything, but if it's not going to work, your program's going to have an issue, right? It's going to break. But I did, in fact, confirm that, okay, this particular object O, if it got to this point, if it got to line 73 in this method, it must have been a friend. So I can actually treat it as if it's a friend. That's what it's doing. The object was always a friend. It's just, according to the reference variable, O, all O knew is that it was an object. That's why I made other, because, oh, well, that's a friend reference variable, and it's happy, and then I can access the methods in the friend class there. Now, one last thing I'll say is we're not done defining equals. In order for our equals to be done, we need to define hash code as well. And that's what we would basically do. It's very simple with simple classes. But we will pick up here on Monday, I guess, or Tuesday, whenever next class is.